members of the Koh Youngs family and the ones which like to be a member. So here we go for our introduction for Koh Youngs itself. So let's dive directly into this. Let's see. Everyone is talking about market leader. We are the market leader because we have the smallest system, we have the largest system, we have the best used system, we have the nice color, we have the fastest system, whatever it is. Because of what? There is no definition of a market leader. And the definition we found for ourselves is following. Everything in numbers. First of all, we are 20 years now inside this area of the inspection measurement system. We invented the 3D measurement, we promoted it, we changed the industry with this, and we are still here. Next thing is we have more than 20,000 systems in the field by today. This is a remarkable number. Next thing is we have more than 3,200 customers worldwide. This is a big achievement. This means not only that we have customers, this means as well we have a very, very good infrastructure in distributors and in partners. You see it by today. I like this audience, I like the place, everything is fantastic so far. And for sure, we are leading the market in market share. Started with the SPI in 2002, switched to the AOI, went to the API systems, gone with the DPI systems, now entering as well the market with the semicon system in Europe. So there is something very, very special at Koh Youngs systems. Most of you people might know this already. What is the special? It's the measurement tool. This is a core competence. Anyway, this is remarkable what we did in the last 20 years, how we changed the market, how we brought our systems to success, and how reliable we work together. So let's see the core competence in inspection itself. What do we want to do? What do we want to achieve? Something changed in between, because from the past it was normally inspection systems were a gatekeeper, avoiding false codes, seeing the detection, and this was a ping pong play. Based on this is what we did as well, but we changed the whole industry by reconstructing and measuring. Based on this is our core competence number one. It's measuring the components, which means before it was somehow inspection in 2D, having a reflection, measuring the reflection, or let's say calculating the reflection. Based on this we had a result. Now we have a height. If you have a height, you can measure this. Doesn't matter what it is, what kind of color do you have, what kind of component do you have, as long as it has a height, we can measure it and we have the result. Means, this is the factor we distinguish from all the others. It doesn't matter how the delivery is. With 2D system, you are heavily related to the delivery of the line. If the component is sometimes black, sometimes yellow, if the paste is bright or let's say not that bright, whatever, if the PCB is green, black, red, whatever, so everything has an effect in 2D. With 3D measurement, you only need the height for this. And this was a big differentiator to all the others in the field. So, one of the core competences. And not only that we are measuring it, we proved it already with third-party developments like the ZetaQ board, that we can measure and that our measurement is the best you can have inside your production. This gives you the, I would say, the freedom to do what you want. Based on the measurement, you can have always precise results. This is a basic of what you need inside your production. Because of what? Based off this, we have the systems, we have the measurement, so what are we doing with this? So we have to go a little bit further. What are we doing with the data? Because what we want to achieve is, we want to control our process. Very simple. We want to see what happened inside the production, we want to control the production, we want to change the production, and we want to do this all in real time. Based on this, we have a lot of tools developed, and we are still developing those tools, which will help you with this, with preparation, with the operation, review, analysis, fine-tuning, and for sure the maintenance. This is what we are doing inside your production to help you to increase the output and reduce the costs. That's very normal, I would say. Everybody wants to have this. But you need something. There were 2 presentations before about automation. Automation is nice, but what you need as well is AI, artificial intelligence. And this is the example for preparing artificial intelligence inside your production. Because you want to train the system, what do you want to see inside your production? How you want to measure your production? We are all humans, and humans which are producing something like to see the success, what they want to do. So let's say when we are producing something, we want to see, okay, how good is our production? We want to measure something. And we want to measure something, what we are producing, based on what we implemented inside this production. Are we successful, or do we have to improve? And this is a helping tool for this. Based on this, in general, except you have never seen this before. Now comes really, really hard stuff from sales side of you. What do we want to achieve? We want to improve the productivity, we want to improve the quality, and we want to reduce the costs. Never seen before. That's the way how we work it. Yeah? That's the simple thing. Based on this, what are the tools we are using for this? First of all, we need trustful measurement. That's what I talked before about. This is what we deliver, and this is what you have to handle. Then, this data has to go through the AI. The AI is trained by your experience, as usual, to bring the best results. And the process optimization will be done after the AI because you want to achieve something. You want to see the results you put inside the system, the force of your production. Because normally, you all know this, okay, you put a lot of force inside your production to set up the systems. And suddenly, these people are gone, so you are losing a lot of experience. But when you are feeding the AI with this, the experience is still staying inside the company. Here we go. That is a big tricky. And this is as well when we are coming again to the completely new world, Industrial 4.0. You have a lack of people, you have a lack of specialists, but you have to fulfill this with AI, with clever software platforms, with ease of use systems, and for sure with reliable data. Otherwise, it will be really tricky. Okay, based on this, what are we doing? Well, here we are. These are the solutions we are talking about. The KPO, the machine-to-machine solution, auto-programming, smart review stations, the K-Smart tools itself, auto-rework, offline program optimization, and for sure, one of the most important things, the self-diagnostic, because you need to check on the hardware. If the hardware is not working proper, what shall the software do? Anyhow, let's start with this. This is the future of, I would say, smart productions. This is what we are working on, and these are the steps when we are going, look up there is no automation, to a fading out person which is not longer involved inside the production because the AI is taking over. When you see this picture, this view here, how we are working with our measurement system with the big data on the tools to bring automation into, let's say, the production with AI, with software solution, you will see the future, what is based on manless production. That's very simple. That is the idea, and this is what we are doing. You see the steps, how we are going through it. This was already done, this was the improved, this is the next one, this is the, let's say, take over suddenly from the AI, and here we go. Other things what we are looking about. The self-diagnostic. What is self-diagnostic? Self-diagnostic is something what you are doing frequently inside your production. Every week, every month, every 3 months, whatever it is. And you are doing all the time the same steps. So, what would be if the system knows by itself what needs to be done? At what time we need to have a maintenance, at what time we need to improve our system based on, let's say, some damages which are inside. As you can see here, it will be alarmed, Then we have a maintenance guide, what will be taken, the machine control takes in, and the traceability, what was done so far, will take over. Means we have several steps inside the AI based on what we put inside, based on what you put inside, that the system knows at what time it has to act and what time needs to be, let's say, at what steps need to be done to fulfill the demand of self-diagnostic. The system needs to figure out how things need to be done when something happens. Based on this, how we are doing this, what is the first step? This is our auto verification board. It's fixed on the rail, and here you can see when something is going in the wrong direction, when you start to, let's say, measure boards, when you start the system, when you reboot the system, when you change the program, it's based on your demand how you want to do this, and this system will figure out if the system, let's say, if the AOI or if the SPI is still in a good condition or it needs to be done. Why do we have this? Because it was a huge request from a big customer in Europe. They said, how can I make sure? And now ask you question this by yourself. How can I make sure when I have to reboot the system that the system is working after the reboot in the same way as before? Guess what? You have a board, you put it inside. And when the errors will be found, you say, okay, it works in the same way. But you have always the same board, and the board gets old, rusty, whatever, dusty. There it is. And with this one, you can verify that the system is working in the same way as before. So you are sure that the system is doing the same job, in the same way, with the same results. And all this will be stored in a database. And you can compare things. The system will tell you yes or no. That's the important thing. And based on this, we can do the self-diagnostic as well. What is different here? Is this the camera? Is this the illumination? Is this the adapter? So, working with this makes you, let's say, safe. You are sure everything is working in the right condition. Have a look here. When errors have to be prevented, when you have to ensure the reliability, and when you have to maintain the system itself. So based on this, you are on top where you can figure out at what time things are under control and at what time things are getting out of control. So you see here, as well as the standards, when you have the monitoring of the PC, the configuration manager, and the search error code, what things are going on inside your system, because it's always a little bit tricky to figure out what is the error code for a message. Yeah? And based on that, this is the maintenance notification which we have to send as well, that everybody is on track what things are doing inside the system. This will be taken over afterwards for sure as well for the at the AI configuration, but in the first step we have to show this as well. So, let's have a look. What we have here, the auto notification. This is going directly to the operators, something covered by AI, because you can do a lot of things with the AI, but we need to announce this as well to the operators. The thing is, if you don't know that the system is doing the right thing, there must be always something a little bit tricky here. So, but we have to show what the system is doing, what will be maintenance, and what will be done in real time to improve and, let's say, to maintain your production itself. And when you have a look here at the steps which needs to be fulfilled for the maintenance, for the monitoring, for the prediction, for the optimization, we are here at this stage. The monitoring, the proactive maintenance, and this will be the next step for the future. Let's see how fast we can do this. Anyhow, the K-Smart technology itself, the software solutions. K-Smart is something, let's say, a word for overall. But what do you want to achieve with the K-Smart solutions? For sure, you want to improve your production. Second of all is the overview you get from your production. And let's have a look. First of all, this is the handling of big data. The decisions which have to be made by, let's say, the human actor inside the production. But now we are giving these decisions to the AI. and the AI will handle those results directly to make the decisions for the operator to get to a faster and to, let's say, in the worst case, the same result, but normally it should be the better result because it's the AI, should be much worse, better. Anyhow, you see here the setup. Everything will be handled by a server, every setting will be done by the server and will be, let's say, forwarded to the inspection systems how to handle it. Anyhow, here you see what we want to do with the process, with the K-Smart itself. The easy changeover, doing with auto-programming, offline program optimization. How to improve the process itself with smart review, with dynamic settings, with some new tools inside the 2D learning. Let's say this is very accurate and this is very dynamic this way. The process optimization, you see the KPO, the program optimization, and the mounter optimization. This is something, an interaction between our inspection systems and the production system itself, and for sure all based on the right settings inside the hardware itself. So things what we need to do. So the K-Smart itself. You see, we are detecting the problems. Second of all, we are analyzing the problem. And the third step will be, we are resolving the problem. By all this monitoring and it's circulating around. Let's say when we are doing something, we need to check it here. It goes to the analyzing and it's in the resolving again. And so this is the circulation of solving a problem via AI. Based on this, let's have a look what we can see here, the K-Smart solution itself and how we are visualizing this. As you can see, I have here the overall equipment efficiency, the machine utilization, production monitoring, everything in one view. Let's go a little bit further. So here's a production chart by, and let's say here are all the systems which are connected. Here is, let's say, the up and down time of the systems. Next step is the production status of the systems itself, how we are working with that. Here, the next step is the defect types, what we are working with, and here are all lines which are connected. As you can see, what is the downtime, what is the output, what is the yield of the system, so on. Looks a little bit too much, but at least you have an overview how your productions are working, and what is the most important thing is you can compare the lines. Who knows what happens with line 1 against line 3 when line 3 is with the same configuration, with the same product, much less efficient than line 1. So then you have to figure out, is the software the same, I don't know, are the settings different, whatever it is, but here in this compare, you can see if there's something wrong inside the production itself. And this is for you a huge effect. And when you bring this experience to the AI takes over and check it out to give you first of all a warning and then an improvement, a suggestion how to make it somehow better. As you can see, process analyzer, monitoring in a real-time chart, in a dashboard, shows the production status and let's say what can be done better. In the analysis itself, what kind of yield do you have, what kind of job you are using, what is the PCB for SPI analysis, and what is the inspection or let's say the measurement itself for the AOI. Everything is well structured and should bring you much more overview about the big data you are using inside your production, because you are working with measurement results. And not only with one or two, you have a lot of measurement results inside your big data, which you want to handle in the best way inside your production. Based on this, we're having a look at what kind of tools we can offer for this. One is the real-time, one is the yield analysis and the job file analysis with the different dashboards what we have here. Second of all are the tools inside the realization. For example, this one, the K-Smart Link. The K-Smart Link show you the process itself. And you can see, it starts with the SPI, goes via, nice and puffy, goes via the pre, production and then the post-reflow. So you can see every stage of your production, which can show you this is how this object or this component were handled. Brings you, let's say, some knowledge about, let's say, how the things are running. But it's not about the picture, it's about the data below. This is a more important thing. This is only the visualization. It's nice for us as humans because we are visual, but what we are looking for are the data. How to set it up in this way. Go to the next step, the ease of use. How to set it up. Offline program optimization. We are talking here about a digital twin, means what you're doing at the system can be handled via laptop or other PCs offline and will be then improved. Like I said, this is a digital twin, offline program optimization at its best. How we are doing this? This is a big, what can I say, advantage of measurement data. You can set up the tolerance in a much more efficient way. Before it was somehow, what can I say, an estimation of reflection based on what the system will deliver you. When the reflection at this pace is in this way, or when the component is suddenly yellow or black, whatever, so it's only an estimation what you have to do here. But when you are measuring the height of components, you have a fixed value. Based on this fixed value, you can place your tolerances and your warning in a much more efficient way. This was always the dream of 2D users. With 3D measurement, it's an easy task. Let's have a look here. The auto-programming, the KAP. And here it's where it really starts with the AI, because the KAP is not loading CAD data, creating a program with 5 clicks, and thinking it's over. Auto-programming. This is only the raw program creation. This is not fine-tuning, this is not production ready, this is only implementing the data. There is a big difference. What we are talking about when we are talking about auto-programming is, there is a board, this board will be implemented inside the system, then the system will reconstruct the whole board in 3D, figure out inside the existing library what component fits to the match, or let's say to the reconstruction on the board itself. And then it will be reconstructed on the board, will be linked inside the database, and based on this, the remaining components where you have no clue what it is, will be tried to figure out. Let's say when it's an SO8, for example, and we don't know, have any information about the SO8 of this customer, the system will reconstruct the component and will find the SO8 because it's a standard component inside the library. This is artificial intelligence and this is auto-programming. It's not based on the part number, it's based on the shape reconstruction information what we have. And what is then the next step? The next step is having this component and then fine-tune this component. Which means with the same board, we have to reconstruct this, we have to fine-tune it, and we have to adjust these components. And then you have a production-ready board. This is a big difference. The fine-tuning we are working at the moment on it. But with the linking of the component, we are very successful. So, what means with the standard? What is not the standard and what is not in the library, for sure you have to create new. The problem is you can't have them all, because otherwise you have a 50,000 component library. So let's say based on your production from time to time, especially in the connectors region, you have to create your own components. There's no way around. By the way, when you have a look outside of, at our Koh Youngs board, you will see that there are some components on it which are not normally a standard inside the libraries. Because of what? Because you know it's a Koh Youngs board. Why we are placing components on boards which we want to show to the customer, which we can't handle in this way? Because it's challenging. Easy can be done by everyone. And why should we show you things we can already do? We are showing you things which are challenging us as well, with the principles of 3D reconstruction and with the principles of auto-programming, for example. Anyhow, that's the way. Loading the board, reading the board, linking the components. Based on this, that's very easy. That's sales stock, 1, 2, 3, everything is ready. It takes its time, for sure. And as I told you, there are obstacles when there are components inside or on the board which are not inside the library. It takes time. So let's say this is the fantastic way. This is the fairyland. This is a nice forest, I would say. Anyhow, this is how it should work and how it will work in the future. Anyhow, you see as well how will be the connection inside the library itself. So let's say, what is the standard of the library? What is the customized setting inside? How it will work? How it will work? And let's say, what is the estimation of this component? Everything what you get is based on this AI then, and then you can estimate what's going on. On the other side, when you see from the standard to the auto programming, you will save 70% of your programming time. Let's say 70% is a nice number, but I would say even 40 or 50% is enough to save. When you know how long you have to take time to create a program. Imagine you will save 50% programming time by creating a program and file debugging. When you know your production and the cost of your AOI usage inside your production, the SPI usage inside your production, it's a huge amount of money you can save. Anyhow, this is what we are waiting for. Program preparation, the mapping, inspection, condition setting, protection preparation, fine-tuning, monitoring, and then the optimization. This is all the stuff which is going step by step to be implemented in the future to feed the AI, having the related tools to create programs. Anyhow, the auto review, that's something I have to speed up a little bit. We all know the effect of review stations. You have all the time the same errors. And suddenly, the one who's sitting there is not looking anymore, it's just clicking, go away. Here, with the smart review station, we are able to reduce these kinds of false code if they are returning. You see here the visualization of the errors, you see here the result of the errors, and you see not what is going on behind. This is the AI is working and the AI is collecting the data, and based on the actions here at the board itself, it will learn and it will judge the component by itself. And this is part of the Lights Out project at the review station. Means you are feeding these objects. Based on this, you see the different components you can handle here, the different part of errors, tombstone, billboard, and everything will be judged afterwards by the system itself. And the system will show you at what time it needs help and at what time it can handle it by its own. This one, very, very important, the case part auto programming, program optimization. Last part, give me 5 minutes, sorry, takes a little bit longer. Anyhow, the program optimization is the interaction between the SPI and the printing system. Based on this, we want to improve the printing process by using our expertise of the SPI. So, well done. First of all, we need to have the handshake, then we need the, let's say, stabilization of both systems together, and then we can start. Based on this, we are testing now 17 boards. Strange number 17, you can use 20 as well, but we know by heart 17 are enough. So based on this, all these boards are done now, collected, and there is an ongoing interaction between the SPI and the printing system. You see here, first of all the setting, then the design of experiment, then the modeling and optimization. Based on this you have a verification, and then you have the inspection result of each board. Having all this information together, we are using then the printer optimization in real time when the boards are coming. Based on these settings we figured out from the 17 boards, it's based on the temperature, humidity and the solar viscosity. This is unique and this is something what helps a lot to improve the whole printing process. How fast it will be, how reliable it is, and how much money you can save. Based on this, when you have a look, you have a very experienced guy for the printing process. Take him 5 hours to set it up. These are the results. Printing, 25 seconds, UPD, whatever, 3.456. The quality, how good it is. And then you see the KPO AI itself. 25 minutes, 18 seconds, 5 whatever, and let's say the print and the printer G. 12% faster, 47% improved, 10 times better. We have case studies about this. This is not only written here, this is the truth. This is what we're doing with our systems when we are connected to the right printer. Autonomous levels, as you can see, again, what I showed you before, this is the way to go. You saw the tools and now you have a better estimate, let's say in the understanding what the tools are for. You see the OCR learning, the KPO, motor optimization, the KPO production optimization, self-diagnostic from phase 1. All this stuff is part of the next step to implement the AI in your production. This means you are feeding the system will understand and will improve your production based on what you want to have inside your production. How to save money, how to make it easier for everyone, and more understandable. Thank you.